All right, we're back at it for day 12. All up to date. We've got 22 stars so far. This is just about halfway. So we've got some hot springs. This is the onsen. Having a lava shortage, so the hot tubs aren't hot. Many of the springs has fallen into disrepair. They're not even sure which springs would be safe to use. Worse yet, their condition records of which springs are damaged, which is our puzzle input, are also damaged. So we'll need to help repair the damage. In the giant field just outside, the springs are arranged into rows. For each row, the condition shows every spring whether it was operational or damaged. This is the part of the condition records that is itself damaged. For some springs, it is simply unknown. Question mark. I don't see any question marks in. However, the engineer that produced the condition records also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order. This list always accounts for every damaged spring, so this list is accurate. And each number is the size of its contiguous group. So 113, 113, okay, that makes sense. And each contiguous group is always fully accounted for, so this can't be 1-2 or 2-1 or 1-1-1 or something. So this is a full list. This is the unknowns. How many different arrangements of operational and broken springs fit the given criteria in each row? In the first line, there's exactly one way to separate groups of 1, 1, and 3. So if we've got 3 empties, there's 3 ways to do that? Oh, there's exactly one way. Okay, yeah, that's what I thought. Second row has 4 ways because we need to put For each row, count all of the different arrangements of operational and broken springs that meet the given criteria. What is the sum of those counts? Okay, I've got no idea how to do this other than to brute force it. Okay, so apparently this is effectively, I guess, a nonogram, or known by a bunch of different names. It's a kind of puzzle. I have honestly never heard of this kind of puzzle. We are restricted to 1 row, and we are potentially given items to remove. So for this 1316, it says there's 1 arrangement. So if it's 6, then that needs to be a dot, but it could be 6 on either end. So why is it 1 arrangement? Oh, are these ordered? Okay, that's really useful. 1, 1, and 3 in that order. Okay, that's really useful, honestly. So it has to be 1, 1, 3 because we've got 3 here and we've got 3 spaces left. We have to fit 1 and 1. So they have to be, I don't know how to programmatically encode that aside from a bunch of different like manual rules. There's a number of different approaches on this Wikipedia page for like how to solve these puzzles. Encoding them seems tedious. I guess my question is, how do we represent a row? I can't think of a better way to do this than to just like manually stuff a bunch of stuff in. So I guess the only way that I can really think of that would be exhaustive and wouldn't require a giant list of shortcuts is to fill the question marks in with alternating lists and see which ones match. So this is 113, right? And we can either have 3 dots, like hash 2 dots, hash dot, like that kind of thing. Like just enumerate everything and then check to see how many of them fit. And I think that's not too bad. Our puzzle input doesn't look that big. Maybe 10 to 15 might be the largest amount we have to solve for, which probably isn't great, but is probably fine. So let's start doing that because that seems like it'll work for the input. Just create day 12, part 1. I think we're going to need to do multi-combination. So first of all, our answer is what? 21. And our input is which thing? Which is the test input here? Is this the test input? First line, second line. Okay, so we've got the full test input, and I think we're going to RS test this as well. So this is going to be a test. So RS test, because this really feels like I'm going to have to pass each of these. We have all of the input for each line. These minuses are the answers. Get all of this in, go to front of line, hash case, open. I think those are all of our cases at least. And then this is test line, I guess. Case input, case output. I don't know, we'll make this an I32 or something. I don't think it matters at the moment anyway. We need to pull in RS test. And now we have tests running, or we will have tests running. Let's set this up immediately with test log instead of just the regular test so that we can get tracing output. So to do this for a moment, but we're gonna have to assert equals something. I guess I'll call this process line on the input, and we'll just take the string. Process line obviously doesn't exist. So let's start with a parser for the line. I'm not sure what this parser is going to return though, right? If we parse this line, we have to split it, right? So we have to get the batches and we have to get the input. I don't know what the input is going to be. So we'll start with pair, I suppose. And I'll just start this off something easy with alt, where it's tag question, tag dot, or tag hash. I feel like I want the whole input though. I feel like what I'm going to do later after we generate everything is iterate over this and then map it and change any question mark to pull from the generated list. It'll be kind of clunky, but I think that's what we're going to do. So I'm not even sure that this is going to be a bunch of different things. So we'll start with is a question dot hash at least. And this is going to be a separated pair. And over here is a separated list, which is, what are we going to use? Complete U32 because it has to be positive. And then the separator is going to be a tag with a comma. And I think there's no spaces. This all takes the input. This is going to be line, and that's going to be batches. Well, to do this, and I missed a paren somewhere. I think that's on the end there. And of course, bring everything into scope. Just work day 12, part 1. And then we see the type error. It takes 3 arguments because, oh, right, separated pair, space 1 here. I didn't finish the tag there. All right, so it was just a parens issue. So now we've got our line and we've got the batches that we need to fit. I don't know that we even, the batches are only going to be used later. So I think we want to get the question marks or count the question marks at least. So I think line and batches is fine. Maybe we store this in a struct. Let's call this puzzle or something. Get our lifetimes in here. Then we get input and puzzle, fill fields, line batches. And then this is puzzle. So parse line gives us a puzzle. Of course, all of our tests are failing, which is great. I think I also want to return in this from this parser the count of question marks. So like spaces, and that's just going to be a number. I'll call this spaces to fill to make it a little bit more obvious because I'm not worried about variable naming length here. So given the line, how do we find out how many question marks there are? So we could do this really sillily. We could do line.cars.filter c not equal or c equals question mark count. And this is an issue because it's a reference. Yep, absolutely. And then puzzle is spaces to fill. So that gives us our actual line, found usize, because it's a count. That's fine. I don't know that I need it to be anything else. Let's just make this a U. Well, let's do a U32 because it won't be that big. It can only be like 1 through 10 or something like that. So we'll just cast this to a usize. So we've got our puzzle, we've got the number of spaces we need to fill, we've got the line as it exists, and we've got the batches that we need to check against. So given a puzzle, we are going to have to call a function that generates the combinations, and this will take a reference to self, and it will return, probably an impl iterator would make the most sense, but let's call it a vec of strings, I suppose, because we'll be generating them. So let's figure out how to do that first, right? Process line will need to input puzzle equals parse line input expect should parse a valid line. So we have our puzzle here. Impl puzzle does require the lifetime annotations because we do have references. We do have unit being returned here. So we'll to do in generate combinations. Let's start with puzzle generate combinations just for kicks. And then this needs to give us every combination of spaces to fill items with a dot or a hash. And there will be invalid combinations here, which is totally fine. We can always work out optimizations later to reduce the number. So we're going to go check iter tools because we need something like Cartesian product, I believe. Returns an iterator that iterates over the Cartesian product of the element sets of 2 iterators. That's not quite what we want. I think we want combinations because we really don't have an iterator. Combinations, this is just going to be for generating the string. So dot hash and hash dot for combinations are the same thing, but for us, the order is going to matter. So permutations is probably what we want, right? 5.8 permutations. So this would be 5, 6, 7. So 5, 6, and we should also see 6, 5. And that's really what we want. We want permutations. If you are looking for permutations with replacements, use repeat n, iter k, multi-Cartesian product. Permutations with replacements. I just want to take a second to understand what that means, because I think we can go with the permutations approach and just continue, but all iterators must yield the same item type. Yep. Iterators vec t. Yep. Multi-Cartesian product, 0 to 3. No, I think we want permutations. I don't quite know what it meant by permutations with replacements. Permutation with replacement calculator. For a permutation replacement sample of R elements taken from a set of n distinct objects, order matters and replacements are allowed. Calculate the permutations. If we choose R elements from a set size of n, each element R can be chosen n ways. So the entire sequence of R elements can be chosen that many ways. That actually sounds relevant, but let's do this instead for now. So let's do generate permutations. This is going to be dot and hash, right? Dot iter dot permutations. And the permutations k is going to be self dot spaces to fill. And let's just do a dot count for that for the moment. And this can go as usize. Process line is what we need in our test, which we are already calling. So we should change that to unimplemented. Case 4. Am I not debugging that out? Did I totally forget? No, I am. Let's get tracing info in here because we already did tracing. We'll instrument this function. We'll instrument this function. I'm going to skip the input here because I always end up skipping the input anyway. And then I'm going to run our test here with Rustlang info. And that was not the right one to use. Rustlang info, cargo next test run, package day 12, part 1, no capture. 2 tests run, 2 failed. So we've got here puzzle, spaces to fill 5, line, batches 113, count equals 0. Count equals 0 feels weird. Is that because 2 elements can't fill 5? So do we actually need, if k is greater than the length of the iterator input, the resultant iterator adapter will be empty. Is this actually what we want with replacements? Repeat n, this, spaces to fill, multi-Cartesian product. I'm going to collect this and get rid of this for the moment. I think repeat n is from itertools. There's also standard. So repeat n in itertools is create an iterator that produces n repetitions of element. So let's pull the one from itertools for now. Get as usize. This is collect. So it needs to be given a type. Once we give it a type, like if I wanted to collect vec unit, it'll tell me now what the issue is. Oh, right. Options needs to be a question mark. Collect is vec reference to car. Item type is a vec reference to car. So it's actually going to be a vec of reference to cars, which could be a string and should be a string, honestly. So we still have a bajillion failing test cases, but now we have 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay, so this looks like what we wanted. I think sticking this as in a string is going to be good enough. Let's do into iter here and see if that solves our issue there. Apparently vec of cars can't be collected into a string, which feels weird, but that's fine. We actually don't need these to be cars per se. Item is vec of string slices here. So maybe we just force this a little bit and then we end up with a bunch of options here that are a little bit easier to look at. That's really why I'm forcing them into a string. I don't need to force them into the string for any real reason, but that looks like all of our options. Some of them obviously invalid, but I'm not worrying about that right now. So let's return that. So we're getting generate permutations, correct? And then what do we need to do with that? We need to insert that into all the right places. So something like options here, right? We're going to have all these options. This puzzle is going to have something like check option, right? And that is going to be, we're going to pass in an option as a string slice and return, I don't know, let's return a bool. So for option in options, something like this. Well, we could do options.iter.map option. Option here is a reference to a capital S string, at which point we can call puzzle check option with the option. I guess this can be filter map. Check option, of course, doesn't do anything yet. So let's to do this for a second and let's check. We'll cargo watch this to keep it going. Associated function, not a method, because check option doesn't actually take anything, but it needs to take a reference to self because I think we're gonna have to check against self, right? That's why I put it on here in the first place. I guess this is just filter, right? We don't need actually the answers technically. And then the return value here is gonna be count, which is gonna be a usize, which I think is fine to just change here. So process line.expect should parse, I guess that's not returning an option, right? Process line. I am making this an I32 in the type signature, which we don't need to do. We could usize that. Okay, so now we have this thing. It's running something. It is not necessarily running what we want it to, but it is running. So let's info count here. Okay, so now we need to implement check option. Let's just say this is false for a second and see it run. Count 0, great. Supposed to be something else. So what do we do to check an option? Select mute option iter. maybe equals option.cars, then self.line.cars.map C, match C, I suppose. If C is a question mark, then option iter.next. And this should always work, so I'm going to expect should have a length similar to needed gaps, and otherwise we just forward whatever value this is. So I'll call this value. This will be value, and then we can let this filled option be that, right? So for every question mark, we fill in, and then right, and we can log that out, and we'll do tracing instrument. This filled option comes out, and then filled option iter group by CC is hash dot iter, right? And then we map over these groups, and in this case it's group, and it's just the count for each of them. And if we collect that, then it should be a vec of what use size is. And let's throw our to-do back in down here so we can get rid of that, some of that squiggle. This, of course, needs to be cars, which we already have up here. So this collect is unnecessary and we can remove it later. Group by, I think this is into iter, right? So then we get bool and group is hashes and group. And this can be filter map. And we can do is hashes dot then sum group count. And that can be counts. And this can be counts. And am I passing a vec in here? I am, so I need to debug that. And what we're left with is check option gives us a puzzle where the filled option starts off like this, and we get one group of two, which does not match batches. So I think we can do here self.batches equals a slice of counts that is everything, and that is just the return type. That's it. Batches also needs to be a slice to do the comparison. Are the numbers the same types? Did I forget to do that correctly? U32 and usize. So maybe batches, when we do a U32 here, we have like two options here. I can go back and change everything, or I can do as U32 for the count. This, of course, then collects into a U32, and that should give us check option and counts 223 and batches 113. So this wouldn't work. And then count is 4. So I think that's correct. Info count, process line. Question is, are the tests passing, or is it just because I have this macro there? 7 tests run, 6 passed, 1 failed. Okay, which one failed is the big question. Oh, test process failed. No, that's perfect. So this works for every line. What we just wrote works. Is there a way in which I want to clean this up? I mean, we could do puzzle.solve here, right? But possible solutions equals puzzle.possible solution count or something. So fn possible solution count, and this is a self-reference, right? And it returns U32 is what we said. And then we pull this stuff up and in. So this is now self.generate and self.check option, which makes me feel a little better about having this just like kind of itered and called. So this will return, what, a U32 now? I guess this should be a U size because we're returning this count, but count, that's all good. That's all fine. Test process panicked, but the other 7 passed, right? Filtered out. 7 tests run, 6 passed, 1 failed. So that's 1, 2, 3, 4, 5, 6 for us. Everything's good to go, at least for processing each line. So now we get to take what we did here and drop it into this process function. This process function, of course, parse line is going to be a combinator. I guess it doesn't really matter how we do this. So let's do input here. Input.lines, map, line, parse line. Of course, because this is the same thing, we can just map with parse line and it'll pass the argument in for us there. Collect. And it's interesting to note, of course, that this parse line, right? Parse line returns an I result. So if we collect, and we can expect on the outside now, if we look at the type here, it says impl iterator item result with a tuple in the first and an error, which is a nom error. So if we look at the type that we've written here, that is the same type aside from, let's say, this lifetime here. And of course, if we're wrapping this in result, we do have to make it a vec of them, which goes around the input here. So this is something I'm going to explain. What I've done here is, and you can see why we usually don't specify the nom error in these parsers, because if we look at iResult here, right? iResult only shows us 2 generics because the error generic has a default value. So in this case, it's iResult string slice for the input, puzzle for the output, and there's a hidden generic here that we could specify, but we usually don't. That's a nom error. That all is a type alias for this type. So it's result, our input type, and then the error, which this is verbose. This is why we have our result in the first place. The key thing here is that because those are all results under the hood, we can move the result out, change this input into a vec, and then if any of them fail, we'll get a failure here. We'll get the ERR. Otherwise, everything will succeed and we'll have a vec of our inputs. So that allows us to expect on this and then get a vec of the input output that we would normally be dealing with. So then we can take that, we can do puzzles.iter.map puzzle this.sum, which I think we're going to sum into a usize. And I will select these two. I'll get sum. And then this is not just puzzle, but there's an input here. So we need to ignore input and just take puzzle. And then we get our puzzle solution count. And this returns okay sum.toString. And if we've done everything correct, all of our tests pass, which they do. So we'll cover this in the deep dive. I wrote this out completely because we're a little bit futzing with things here. So we've got our regular result, we've got a vec of our inputs and outputs, and then we've got the error that could have happened in any of them. And collect lets us take what would have been a result over these, the I result, and move that to the outside if any of them fail. So we already have our input. This looks like it's taking a while, which is not my favorite. Make sure to run it in release mode here. I hope part 2 doesn't expand the rule set. Let's see if that's correct. That is correct. Gold star. Go to the next one. As you look out at the field of springs, you feel like there are way more springs than the condition records list. When you examine the records, you discover they were actually folded up this whole time. To unfold the records on each row, relates the list of spring conditions with 5 copies of itself separated by question mark, and replace the list of contiguous groups of damaged springs with 5 copies of itself separated by comma. So this row, dot hash, would become 5 copies of dot hash and 5 copies of 1. Oh, this is just going to run forever, isn't it? All right, well, let's get started by pulling this into the next one. Looks like all of the same, except for the answers are different. So let's get 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And then this last one needs that 0 taken away. Get rid of the rest of that text. This should all work for process line for part 2, which it won't right now, which is great. And then the ultimate answer, of course, is this giant one. So let's start running our tests. I'm not gonna run it with info right now. So we'll run part 2. We've got 7 tests run, 2 passed, 5 failed. 2 shouldn't pass, but that's fine. I think that those are the ones that are only 1, so they don't change the answer. Yeah, so 1 and 1. So they both need to be repeated, right? So in our generate permutations, we've got this, we've got spaces to fill, but our parser then needs to account for this. Do we use line anywhere? We do, right here. So we need to calculate that line. It'll change the type, right? Because we're going to have to turn this into like 5 copies of itself. So that'll become a capital S string. This lifetime will go away, which means that in our implementation, this lifetime will go away. We could have kept that as an ID. Probably would have been useful, but that's all good. So we've got our line. We've got our separated list. The data we're keeping here isn't that bad. So I think line, some kind of repeat 5 and then collect kind of thing. Is it always the same number? 5 copies of itself. So dot hash goes 1, 2, 3, 4, 5. Replace the list of spring conditions with 5 copies of itself separated by question mark, and replace the list of contiguous groups of damaged springs with 5 copies of itself. So it's dot hash joined with a question mark. So str has repeat, but that will just repeat it in a row. So I think we want the iterator repeat. Creates a new iterator that endlessly repeats a single element. That's pretty good. So iter.repeat the value, take 5, and then we can join that. So what? Standard iter repeat line.take 5.join question mark. Is that going to work for us? And then batches is the same way, right? So batches has to be batches repeat take 5 flat map or flatten. Flatten is probably fine here. And then we collect into a vec of whatever, which is the type in the struct, so we don't need to annotate it. So this should work. Should have a length similar to needed gaps. Does the number of question marks change? I guess the number of needed gaps does change, right? So the first line of the above example would become question mark, dot hash, 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 question mark for the join, and then it repeats. So I think all we do for batches here is what we were doing before. So spaces to fill is now going to be this. We'll go expanded line. let expanded line equals this. Spaces to fill then is done on expanded line. Name those variables correctly. And then batches also needs to be repeated. Oh no, our benchmarks are running. Crap. Oh no, that's not a benchmark. I think that's just a test that runs way too long. That's not good. If our tests are running that long, that's not good. Expanded line, spaces to fill, batches, memory allocation of bytes failed. That's not good. Okay, so these just get massive, don't they? What is our input? Is it that big? It doesn't look that big. 1, 2, 3, 4, 5. I guess we are collecting into a vec at some point. So we run these tests, right? Repeat batches, take 5, flatten. Case 1, 2, 3, 4, 5, whatever. Yeah, the test failures are failing for byte allocation issues. That's not good. So we can't actually brute force this. One of the issues is that probably we could get rid of allocation here and generate permutations. Because we could, instead of what we have here, impl iterator item equals string, and then this deletes, and then we have to use it differently. So options generate permutations .iter. We don't need .iter because it's already an iterator. So let's pull this into right here. And then we aren't getting the memory allocation issue anymore. So that seems to be the right spot. It does concern me that these are taking so long. If these tests are taking so long, how long is the actual input going to run? That said, we do have a passing test. So this logic is correct, even if it is kind of pathological. Okay, so these tests are taking very, very, very long. We did get rid of the memory issue just by swapping to an iterator, which we already had really. And we could get rid of it again here. So the filled option is already an iterator. There's no reason for us to do that and then again iterate over it. But these are taking like multiple minutes to run. Which one of these passed? Case 1 passed. Is that the smallest case? Pretty much. So one thing we can do is throw in Rayon, at least to see if, that doesn't work for the tests though. Those will still run that slow. So I think at this point, it's probably safe to say that brute force is not going to run in an acceptable amount of time. I haven't exactly done any optimization here. I haven't done any performance work to see if I could get it to run faster for any reason, doing it anyway. But if we look at the input, right, and we take, let's take one of the longer ones here. So if we got this, 2, 3, 4, 5, right? And then 1, 2, 3, 4 for the joining. So like 1, 2, 3, 4 for the joining. Then we have 74 question marks. So I think that number is 2 to the 74th, which means we've got one with 22 zeros combinations, or not combinations, not in the mathematical sense, but that's a lot. That's more than we can check. So I unfortunately cannot think of another way to do this. At least I can't come up with a solution that doesn't require me to write out 20 million rules for how to insert things or determine the possibilities of, I guess. Okay, so for part 2, I am going to have to do a very different approach, something that is not brute force. I've looked into it. I know what the approaches are now, but I will have to handle them tomorrow. So let's cover part 1. For part 1, we split it up into 2 test groups, one that is the full input and one that is each line individually. We do the same thing for part 2. We started off by building out a process line function that included a parse line and then some functions on a puzzle struct to produce the possible solution count. Parse line uses separated pair and separated list to return us both the line itself, the full list of characters, as well as the batches that we need to fill. We use that information to also calculate the number of spaces we need to fill by checking to see how many question marks there are. We store that in this struct, line, batches, and spaces to fill on puzzle, which is also where we input our logic. So for a single line, we parse that line and then we call this function possible solution count on puzzle. That calls generate permutations and then filters based on whether those permutations are valid or not. It's a very brute force solution. We generate everything that we could possibly fit into the question marks, and then we filter for the ones that don't check as valid against the possible groups that we have. So the generation comes from itertools mostly for us, and it's this infinite iterator of dots and hashes, or rather not infinite, but the size of spaces to fill that we then multi-Cartesian product with itself, and we join using an empty string. That gives us every possible combination of dot and hash for the number of spaces that we need to fill. Now, the issue with this in part 2 is that that becomes very, very large. But for part 1, brute forcing is fine. So once we have this combination of all of them, we need to take each one by itself and check it to see if it is actually valid. We do that by iterating over the option. So we given some potential solution to all the question marks. We iterate over each of the characters in our option, and then we iterate over each line. Every time we hit a question mark, since we're mapping over every character, we can change that question mark into whatever we want. We collect that into a string. We don't, strictly speaking, need to collect this into a string because we just turn it back into an iterator immediately anyway. But I did want to log out this filled option at this point. So we take that option that has been filled in with these option characters. We group everything by whether it is a hash or not. We effectively get a Boolean value telling us whether this group is a group of hashes or not, as well as the group of hashes. For us, in this case, we take the group, we iterate over it, and we count the number of items in it. Then we collect that into a vec of U32s, and we check to see if the batches, so our numbers for the groups, matches the numbers for the groups that we've calculated. So if we've got 113 in our slice for batches, and we've got 113 in our counts slice, then we're good. Everything's great. Otherwise, these don't match, and this is not a valid option. So that's our Boolean return value. We can expand this into being a full solution by iterating over each line, parsing each of the lines. We expect these all to pass, so I use a trick with collect here to take a result, which is wrapping all of the nom stuff here. If we look at nom, and we go to the error, or rather, if we go to iResult here, we can see that the iResult type is just a new type, or a type alias rather in this case, with the I, O, and E generics. The E generic is our error type. That is defaulted. We never specify that on our own because we haven't worked that way yet. And then the I and the O are the success value for our result. So the iResult represents a value that is a result of a tuple with our input and our output, and then an error, a nom error specifically in the error slot. So if we break that down and we use that here, this is our input and our output type, and here's our error. But because we're bringing this result to the outside, collect is locking in all of our successful values into a vec of those values. So this gives us a single result instead of a vec of results that we can then expect on to unwrap and get our puzzles. For each puzzle then, we have to solve each puzzle and get the possible solution count and then sum all of those together. This all works, it's fine. But if we benchmark this, even our benchmark takes ages to run. If we run in release, it takes about 2 seconds. Now this is more or less fine for part 1, but for part 2, the runtimes kind of explode. So our benchmark for day 12 right now, if we let all of that run, ends up being about 2.6 seconds. So much slower than anything else we've done so far. That unfortunately makes part 2, when we have to expand everything 5 times bigger, a problem. So I have some ideas to optimize for part 2 and get it done, but that's not happening tonight. So I will see you in the next one for part 2. Have a great rest of your day, and I'll see you in part 2.